Hey, fifth graders, this week we're going to go through a lot and we're going to start by reviewing factor trees. So go back to page 98 in your book. You're not going to have any classwork on factor trees today. I just want to go back through and review it with you. A lot of you, I would say most of you, understand it now and you're good, but I do want to review it just because it has been a little bit since I've done it with you. So let's do one like 90. We call this prime factorization. So what we do is we want to take this number, which is composite, and break it down into prime numbers. So in my head, I say what makes 90, and we're multiplying, not adding. So I would say 10 times 9. Okay, now both of those numbers are also composite, so I need to break them down to a prime number. And you have to know that what a prime number is. A prime number is a number that you can only get to it by multiplying that number in itself, like 2 or 3 or 5. I can only do 5 times 1 to get to 5. I can only do 3 times 1 to get to 3. And I can only do 2 times 1 to get to 2. However, 10, I can do 5 times 2 or 10 times 1. When you're making your factor trees, you don't want to do 10 times 1. You're just going to be doing it over and over again. So you're going to do 5 times 2. Then I'm going to look at 5 times 2. Both of those are prime, so I'm going to circle them and be done with that one. Then I'm going to go to 9. For 9, I get to it by doing 3 times 3. 3 is also prime, so I can stop. So to make my prime factorization, I would list all of these numbers out in a special way. It doesn't really matter what order you go in, so we can go in this order. We can do 5 times 2 times 3 times 3. However, it is a lot better if we do 5 times 2 times 3 squared. That little exponent here squared tells me that we have 2 of these 3's. So that would be our final answer right here, okay? When I was looking at your work last week, everybody did really well on that, so I'm not so worried about that, but let's do a couple more. And then we're also going to look at some GCF, and we're going to have an open book, open notes test this week. It'll be super easy. If you kept up with all the work that I corrected last week, then you should be fine, and we'll go over some more of that too. So let's do one like 88. 88 is a composite number because I can have a lot of different ways to get to 88. The thing that comes to my mind first is 11 times 8. 11 is a prime number, so I'm going to go ahead and circle that one and be done with it. I can't break that down any further. And then for 8, I can do 4 times 2. 2 is prime, so let's circle it. And to get 4, I do 2 times 2. 2 is prime. So my prime factorization would be 11 times 2 to the third. And remember, I do my exponent because I have 1, 2, 3 of those 2's right there. So my final answer would be 11 times 2 to the third power. Okay, let's do one more because I really feel like most of you have it now. It's just been so weird with us being out of school and then some of you being virtual who are not used to being virtual. I just want to make sure we have everything down before we go on. All right, let's do 50. Lots of different ways to get to 50. The easiest path, instead of doing 25 times 2, well, it can be either way, but I'm going to do 10 times 5. And the reason I'm going to do that one is because I already know 5 is prime, so I only have to do this one, 5 times 2. Prime, prime. So my prime factorization, or my answer, is 2 times 5 squared. If you put 5 squared times 2, that would be fine too. So that would be your answer to that. Okay, so now let's move on to greatest common factor, which is what your classwork is going to be on today. Greatest common factor is important because when we get into fractions next week, well, the end of this week really, you have to know how to reduce a fraction, and you have to reduce by using greatest common factors. So let's get to page 100. The classwork you're going to do today is not in your book. It's going to be a worksheet, and then the homework will be a worksheet as well because we've used up all of the stuff in our book. But with greatest common factor, you can have 2 or 3 numbers. You could even have 5 numbers, but we're not going to give more than 3 here. So let's do something easy like 4 and 8. The factors are the numbers that you can multiply to get to 4 or to get to 8. So to get to 4, I know I can do 1 times 4, and I can do 2 times 2. You don't need to put 2 twice. You just need to do that. So what I'm saying here is I could do 1 times 4 or 2 times 2. Those are all the ways to get to 4. Some of you messed up on the classwork we did because you didn't do all of them. And that's where divisibility rules come in because you have to know those rules. So to get to 8, I can do 1 times 8, and I can do 2 times 4. All of those are the factors of 8. Then to find my GCF, I'm going to look at what number they share that's the highest. It's not going to be 1. 1 here, they both share the 1, yes, but they both share a higher number here, which is 4. So it's not going to be 1, not going to be 2. Our GCF is 4, okay? You have to list out your factors before you can tell me the GCF. Okay, so let's do another one. The ones like we just did are super easy because they're small numbers. Bigger numbers are going to be harder. Let's do one like 12, 15, and 18. This one is a 3-part. So I know for 12, I can do 1 times 12. I can do 2, sorry, let's do 2. 2 times 6, or I can do 3 times 4. So my factors for 12 are 1, 2, 3, 4, 6, 12. Your factor is not going to go higher than this number right here. That's the highest number you can get. 15 is 1 times 15. I can't do 2 times anything. I can do 3 times 5. Can't do 6, 7, 8, 9, 10, 11, 12, 13, or 14. So my factors for 15 are 1, 3, 5, and 15. For 18, I can do 1 times 18. I can do 2 times 9. And I can do 3 times 6. Nothing with 4, nothing with 5. And then we already have 6, and then it goes up to 18. So now we're going to look at what numbers they share and pick the one that they share that's the highest number. So they all share a 1. They don't all share a 2. They do share a 3. They don't share a 4. They don't share 6. So our GCF is going to have to be 3 here. Let me double check. Yes, 3. So what you're going to do is list all the factors out, find the one that they share, and list it. So let's do one more here, and then I'm going to let you do some classwork. The ones that are on classwork and homework are pretty easy. I don't think I have any numbers bigger than 60 was what I set it at. All right, so let's do 45 and 60. So bigger numbers. Let's start with obviously 1 and 45. Then I'm going to go to 2. I can't do 2 times something to get to 45, and I know that because it ends in a 5. 3. So let's check our divisibility rules here. 4 plus 5 equals 9. So 45 can be divided by 9. 3, sorry. So let's go over and divide it. So then that tells me that 3 times 15 equals 45. 4 won't work. 5 times 9, you know that would work. 6 won't work because 2 doesn't work. 7, no. 8, no. And then we already have 9, so we're done. Then we can go to 60. I know I'm going to have 1 times 60. It ends in an even number, so I'm going to have 2 times 30. Then we could do 3 into 60. 3 goes in 2 times. So 3 times 20. And then we can try 4. 4 goes into 6. I'm going to try squeeze it in there. 4 and 15. Let me erase this work down here. We know that 5 will go into it. So let's do 5 into 60 if you don't know what it is. So 5 and 12 work. 13, 14 not going to work. And then we already did 15, so we can stop because we're already there. So now let's look at all these numbers. They all share a 1, but I think we can go a little bit higher than that. They both share a 3. They don't, yes, they do. They both share a 5. 9, they both share a 15. So 15 is going to be our GCF here. That's the highest one we can get to. So this is your GCF. So today what I want you to do is work on those 2 worksheets for classwork. We're going to have an open book test on Thursday, and we're going to spend the rest of this week reviewing. Yes, okay. So we got one more thing we're going to do on Wednesday that'll be new, or actually tomorrow that'll be new. Wednesday review, Thursday test, Friday something new. Okay, so I'm going to clear this. This is the end of Monday's video, and I'll see you for Tuesday. All right, Tuesday video. We're going to be on page 102. So 102 today. We're not going to do the whole thing here. We're not going to do estimation. We don't need to waste our time with that right now. So look at the top. It says you can use a number line to help determine if a fraction is closer to 0, 1/2, or 1. If the numerator is much less than the denominator, the fraction is closer to 0. So if you have one like this, 2 12ths, this is the numerator. You have to know that. We did that last year, so I hope you do. And this is the denominator. If this top number is a lot less than this bottom number, it's closer to 0. So we would say 2 12ths is closer to 0. Then it says if the numerator is about half of the denominator, then it's closest to half. So if I have a number like 7 12ths, my top number 7 is really close to half of 12, which is 6. So this one is closer to 1/2. And if the numerator is about equal to the denominator, then it's closer to 1. So if you have something like this, 11 over 12, that means that if I have a circle split into 12 parts and 11 of them were filled in, then it's going to be closer to 1. It's almost full. So let's recap what we did. If the top number is a lot less than the bottom number, it's closer to 0. If it's about half, it's closer to half. If the top number and the bottom number are really close together, it's closer to 1. So let's do some examples of that. You're not going to have a whole bunch of this. That's why we're going to fly through this in one day, because it's really not something we need to spend more than one day on. But I do want to make sure you know what we're talking about. So if I gave you something like 21 over 43, and I asked you if it was closer to 0, half, or 1, I'm going to look at 43. 43, let's round that down to 40. Half of 40 is 20. So 21 is about half of 43, so it's closer to half. So look at what I did again. I said 43 is about 40. 21 is about 20. 20 is half of 40, so 21 over 43 is about half. All we're doing is kind of rounding to where it is. If I gave you one like 5 over 38, that 5 is really far away from 38. So that whole fraction is closest to 0. If I gave you one like 45 over 47, 45 and 47 are really close together, so it's closest to 1. So all you're doing is looking at that fraction and deciding whether it's about a half, is it closer to 0, or is it closer to 1? So that's what you're going to do for a few of them. Then we're going to look at equivalent fractions, which is super, super easy. We did equivalent numbers at the beginning of the year with decimals, where we added zeros to the end of the decimals, and you guys were super amazed at how easy it was. So we're going to do some of that. If you look at the bottom of the top of page 102, equivalent fractions are equal and name the same point on the number line. So if I have something like 2/6 and I want to make an equivalent fraction, equivalent means that I multiply or divide by the same thing on the top that I do on the bottom. So I can pick any number. So I can do 2 times 2. It doesn't matter what you multiply by as long as it's the same on the top and the bottom. So then 2 times 2 is 4. 6 times 2 is 12. So my equivalent fraction would be 4/12. Let's do another one with 2/6. Say I chose to multiply it by 3 this time. 2 times 3 is 6. 6 times 3 is 18. That's another equivalent fraction. Equivalent just means that if I were to reduce them, they would all reduce to the same thing. We're not there to reducing just yet, but equivalent fractions, just know how to do those. So let's do some more. There's two ways to do equivalent fractions. You can do it by multiplying or by dividing. So let's do some more by multiplying, and I'm going to put that here. So let's say I have 6/8. If I wanted to do times 5, I could do that. So 6 times 5 is 30. 8 times 5 is 40. Done. If I wanted to do 6/8 times 2, I can do that. 6 times 2 is 12. 8 times 2 is 16. All of these are compatible. Okay. Let's do another one. They're really easy. Don't think too hard on this. Not everybody will have the same answer too. There's a bunch of different answers you can have. Let's do 10/11. Let's just do it easy, times 2. Remember, it has to be the same on the top and the bottom. 10 times 2 is 20. 11 times 2 is 22. Let's do 2/5. Let's do 5 this time. Most of the time, you're just going to do 2 and 3 to be so much easier. 2 times 5 is 15. 5 times 5 is 25. So that means that this number and this number are equivalent. This number and this number are equivalent. All equivalent means is if I were to put them on a number line, they would end up at the same spot. It's easier though with these numbers because they're smaller, and that's why we're going to reduce. So that's how to do it with multiplying. Super, super easy. Now let's look at how to do it with division. Sorry, there's not an easier way to erase it all. Okay, now for division, it's the same way. You just have to divide by the same number on the top and the bottom. So let's do 15/75. We can divide each one of them by 15. So 15 divided by 15 is 1. 75 divided by 15 is 3. Make sure. No, it's not. It's 5 because I can't read. Sorry. So 1/5. So this number and this number are equivalent. The only thing different is we divided instead of multiplied. If we did 15/75 and we divided each one by 3, 15 divided by 3 is 5. 75 divided by 3 is 25. So that's equivalent. That's equivalent. The only thing I want you to make sure you know here is that you have to do the top and bottom by the same number, okay? So today you're going to do some classwork in your hardback book. You're going to do, let me pull it up on my Shelby real quick, page 102 to 103. Now listen to the numbers you're going to do because you're not going to do them all. You're going to do 1 through 6, 25 through 27, and then 31 through 33, 49 through 51. It is not a whole lot, so don't freak out. But let's look. So 1 through 6, you're going to have to tell me whether it's closer to 0, half, or 1. So all your answer needs to be is 0, half, or 1. 25 to 27, you're going to make equivalent fractions with multiplication. You need 2 equivalent fractions with multiplication. 31 through 33, you're going to give me 2 equivalent fractions with division. And then 49 through 51 is a fill in the blank kind of one. So let's look at that real quick. So for numbers 49, you're going to get one like this. You're going to get, let's say, 32 over 40 equals 4 over n. And you're going to have to figure out what n is. So I'm going to do it and say 32 divided by what gives me 4? 8, because 8 times 4 is 32. So then I just do 40 divided by 8, and I would get n equals 5. So you're going to figure out what they multiplied or divided by, and then you have to look at this too. If a bigger number is here and a smaller number is here, then they divided. If a bigger number is on this side, then they multiplied. So they're dividing 32 by 8 to get 4. So then you do 40 divided by 8 to figure out the answer, which is 5. Okay, so that's what you're going to be doing today for Tuesday. And then Wednesday, I'm going to see you back here for some review. Oh, Tuesday, hold on, we're not done yet. Homework is workbook page 77. Okay, so just some more practice with this. All right, I'll see you guys for Wednesday. All right, our Wednesday video, today we're going to do some review. So let's look at page 116 and 117. I'm going to list the numbers we're going to do. 1, 2, 5, 6, 13 through 15, and 21 through 23. So let's look at these together and see what we're going to look at. All right, so if you look at page 116 at number 1, it says create a factor tree for each number. You're going to do that for 1 and 2. So for 1 and 2, create a factor tree. Now number 2, the number is 126. The easiest way to do it is it ends in a 6, which is an even number. So find out what you can multiply by 2 to get 126, and then take it from there. Numbers 5 and 6, you're going to do the same thing, but you're going to do the exponent with the answer. So let's do number 5 together real quick. If they gave you 20 on number 5, you would do 5 times 4, 2 times 2. So our answer would be 5 times 2 squared. So that's your freebie answer for number 5. You're going to do it just like that. Same thing for number 6. Then you're going to skip on down to 13 through 15. Okay, let me clear this. 13 through 15, you're doing the GCF only. The directions say to do the greatest common factor and the least common multiple. We haven't learned least common multiple yet. That's later on. So the only thing you're doing on 13 through 15 is finding the GCF of those two numbers. And then 21 through 23, this one also has a different set of instructions. So look at that with me. For 21 through 23, you're going to tell me, is it closer to 0, half, or 1? Then you're going to give me 2 equivalent fractions. So on 21 through 23, you have 2 things to do here. Well, actually 3. Tell me, is it closer to 0, half, or 1? And then give me 2 equivalent fractions. Okay, so that's what you're doing today. Your homework is to study, and then tomorrow you'll have an open book test. See you for Thursday. So today, Thursday, you're going to have your open book test. You can use your book, You can use your notes. You can use this video if you need to. You can use any of those things to help you. Anything we did last week with, or the week before with virtual learning, any of those things you can use. Do your best. And then tomorrow we're going to start something new. So I'll see you back for Friday. All right, Friday, we're going to start our next little bit. We're going to be on page 106. So on 106, we're going to be going into the least common multiple, I believe. Yes, least common multiple. These are almost like greatest common factor, but I think these are a lot easier. You have to know your multiplication tables or you won't be able to do these. So look at the top. The multiples of a whole number are the products of that number and 1, 2, 3, 4, all the way on. Multiples that are the same for 2 or more numbers are called common multiples. What are the common multiples of 2 and 3? So if we look at 2 and 3, all you're doing is repeating your multiplication facts. So we're counting by 2s. 2 times 1 is 2. 2 times 2 is 4. 2 times 5 is, 2 times 3 is 6, 8, 10, 12, 16. We're just going to count by 2s, right? 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, all the way on. Same thing with 3. 3 times 1 is 3. 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21. Now we could go on infinitely. It doesn't stop. You can't do that because obviously you would run out of room. So get to about 5 or 6 where you feel comfortable stopping, and then you find what is the least number that they share. So sometimes you will have to go further than you did. Sometimes you don't have to. With 2 and 3, we can already see what is the smallest number they share, which is 6. So the least common multiple is 6. So if you look back into that little box at the top of 106, it says you can find the least common multiples of 2, 3, and 4. So we can go on to the same thing. What you're going to do is list out all the multiples and then just find which is the smallest one they share. It's almost like the opposite of the GCF. So let's do another one. Let's do 3 and 4. So we're going to count by 3s. 3, 6, 9, 12, 15, 18, 21. I'm going to stop there because I ran out of room. 4 is 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 16, 20, 24. I'm going to stop there. So now I'm going to look and see what is the smallest number they share, and I see it's 12. So my LCM is 12. So these are my multiples. The smallest one they have in common for least, L is least, is 12. So that's my answer. So it's really not bad at all. I think these are so much easier than GCF, and that you'll have a pretty easy time with these. Okay, so let's do another one. Let's do 5, 10, and 15. Let's do 3. So we're going to do 5, 10, 15, 20, 25, 30. Now let's count by 10s. 10, 20, 30, 40, 50. And if we're doing 15s, it's 15, 30, 45, 60, 75, and we can stop there. So now let's look at which number they all share that is the smallest. So I see 5 up here, but 10 and 15 don't have that. 15 won't have the 10, so that won't work. 10 won't have a 15, so that won't work. So it looks like our smallest one they share is 30. So our LCM of 5, 10, and 15 is 30. Okay, so that's what we're going to start working on today. You're going to do page 106, numbers 1 through 12. So if you look at 1 through 12, it doesn't even tell you to find the LCM. It just tells you to find the first 8 multiples. So let's do number 1 together. You're going to do them all just like this. So number 1 is 5. So the first 8 multiples of 5. So we're going to go all the way up to 5 times 8, which is 40. So we're going to go 5, 10, 15, 20, 25, 30, 35, 40. So let's double check. We have 1, 2, 3, 4, 5, 6, 7, 8 numbers, which is the first 8 multiples. So all we did was do 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6, 5 times 7, 5 times 8. So for number 2, you're going to do 7 times 1, 7 times 2, 7 times 3, all the way up to 7 times 8. And that's what you're going to do for all of them. It is really easy, okay? So this is what you're going to do today. There is no homework because it's Friday, and this will be all. So I will see you guys next week. Bye.